So here I have a complicated charge distribution. In fact, I've got two charges, plus Q and minus Q, and they're surrounded by a variety of different surfaces, right? You have to find the flux through each of these surfaces, A, B, C, and D. So both of these charges are making up a rather complicated electric field, which is indicated by these field lines. And so you have to find the flux of the electric field through each of these surfaces, A, B, C, and D. And let me just put this up on top hat. Okay, so it should be on top hat now. All right, so please put in your answers since we are running out of time. Okay, so I'm closing the poll now. Let's see what you guys did. All right, so the correct answer is A is the correct answer. Okay, so this is the correct answer. And let's just make sure that we are all absolutely clear about this. So how do you calculate flux? So flux is the surface integral of the electric field over a particular surface. But clearly, we know nothing about the electric field. We know nothing about the surface. So we obviously cannot directly do the surface integral. So what we want to do here is calculate the flux using Gauss's law, because we know that the flux over a certain Gaussian surface just means any closed surface, is equal to the charge enclosed by the surface divided by epsilon 0, right? Okay, and so it's a lot easier to just find the charge enclosed by the surface. So let's start with surface A. So what is the charge enclosed by surface A? What charge is enclosed by surface A? What charge do you see sitting inside surface A? Plus Q. That makes sense? And so according to Gauss's law, the flux of the electric field over the surface A is simply going to be Q divided by epsilon 0, right? And let's look at surface B. What charge is enclosed by surface B? It's simply this minus Q charge, right? And so the flux over surface B is going to be minus Q over epsilon 0. Notice how incredibly difficult it would have been to directly calculate the flux with a surface integral. It would have been horrendously difficult, but with Gauss's law, it's just trivially easy. And what about surface C? What is the total charge enclosed by surface C? Anyone? Surface C is the big surface.
0.
0, because there is a plus Q and a minus Q, right? So the total charge enclosed by surface C is 0. And what about the total charge enclosed by surface D? That is also 0 because there is no charge inside surface D. And so the flux over surface D is going to be 0. Now, in the 2 minutes that I have, let me just quickly physically interpret this answer. So surface A, all the field lines that are cutting surface A are going out of the surface. Do all of you agree with that? So the flux should be positive. That makes sense? Because the field lines are cutting the surface on their way out. And that is why we got a positive flux for surface A, right? Now, all the field lines which are cutting surface B are going into the surface. Do you agree with that? And that's why we got a negative flux for surface B. That makes sense? And what about surface C? There are some field lines which are cutting the surface on their way out, like this one. But you can see that all of these field lines eventually come around and cut the surface again on their way back in towards the negative charge, because the field lines are basically coming out of the positive charge and going into the negative charge, all of them. And so some of them cut the surface on their way out, but they will eventually just wrap around and come back. So the same number of field lines which are cutting the surface one way are also cutting the surface the other way. And so that is why the flux is 0. Do you agree with that? And the same thing is true for surface D. The same field lines that are cutting the surface one way are also cutting the surface the other way. So this field line is cutting it on its way in and cutting it on its way out. And so that is why the flux is 0 for surface D as well. Is that clear to all of you?